Welcome to The Explainer. Today, we're going to cut through all the noise and really get to the heart of one of the most talked about technologies out there, blockchain. We're going to break down what it is, how it actually works, and why so many people think it might just change, well, everything.
So, let's kick things off with a problem that, honestly, is at the heart of our entire digital world: trust. Think about it. How do we really trust the information we see online? How do we know for sure it hasn't been copied or faked or secretly changed?
And yeah, this is a huge challenge. As the Czech National Bank points out, anything digital is just so easy to manipulate. The risk of someone fudging the numbers or even just making a simple bookkeeping mistake is a massive concern. And this is exactly the problem blockchain was invented to solve.
Okay, so how on earth does this technology build trust in a world where it's so easily broken? Let's dive into the core mechanics because the idea behind it is actually pretty brilliant and surprisingly simple once you see it.
It all starts with something called a block. Now you can just think of this as a secure page in a digital notebook. This block holds some data, say transaction details, and it gets its very own unique digital fingerprint called a hash. Now think of this hash like a unique wax seal on an envelope. If you change even a single comma inside, that seal breaks. And crucially, each new block also holds the unique hash or seal from the block that came right before it.
And this is where the magic happens, where the chain part of blockchain comes into play. The hash from block 1 becomes a part of block 2. Then block 2's hash becomes part of block 3, and so on and so on. This creates this incredible, unbreakable cryptographic link. It's not just a list of blocks. It's a chain where every single new link makes all the previous ones even stronger.
So what does that mean in practice? Well, this cryptographic link, it's the secret sauce. If a hacker tried to go way back and change the data in, let's say, block 2, its hash would instantly change. That change would immediately break the chain with block 3 because the hashes wouldn't match up anymore. And not just one person would notice, the entire network would see this broken link and just reject the change. It's instantly obvious.
And all of this leads to the absolute core principle of blockchain: immutability. It's a fancy word, but all it means is that once a record is on that chain, it is permanent. It's set in stone. It can't be secretly changed or deleted. What you're left with is a secure, trustworthy history that everyone on the network can rely on. But here's the thing. An unbreakable chain is only half the story. What good is it if one person or one company controls the whole thing, right? The true revolution is in where that chain is actually stored.
You see, most systems we use today are centralized. A bank, for example, holds one big master ledger. Blockchain just flips that idea completely on its head. It's decentralized. That means a copy of the entire chain is held by every single participant in the network. There's no master copy. There's no central server to attack, which means there is no single point of failure.
And this is so important. This decentralization means no single person is in charge. For a new block to be added to the chain, a majority of the computers in the network have to all agree that it's valid. This process, called consensus, makes it pretty much impossible for any one person to cheat the system.
Now, this whole model isn't a one-size-fits-all kind of deal. You've got public blockchains like Bitcoin or Ethereum, which are totally open. Anyone can join in. But then you also have private blockchains, which are often built for businesses that want that same security and transparency, but only among a trusted, pre-approved group of partners. Okay, so we've got this foundation of trust, of immutability, of decentralization. Now the applications, they go way beyond just money. Let's look at how this technology is actually solving some real-world problems.
Let's talk about supply chains, for instance. Companies can use blockchain to create this perfectly transparent, totally tamper-proof record of a product's journey. De Beers, for example, uses its tracker blockchain to track diamonds literally from the mine all the way to the retail store, guaranteeing their origin and that they're conflict-free. And it's not just physical goods. It's totally changing the game for artists and creators. In a world where a digital image can be copied a million times, how do you prove who owns the original? Well, by creating a non-fungible token, an NFT, an artist creates a unique, unforgeable certificate of authenticity right on the blockchain, forever linking them to their creation.
The potential here is huge, even extending to some of our most critical systems. Just imagine a voting system where every single vote is a secure transaction on a blockchain, completely transparent and impossible to tamper with. Or think about your medical records, stored so securely that only you hold the private key to grant a doctor access. Okay, but for all this incredible promise, and it is incredible,
blockchain is not some magic bullet. It's really important to take a step back and look at the pretty significant hurdles this technology still faces before it can really go mainstream. So this is kind of the tug of war we're seeing right now. On one side, you've got this incredible promise of perfect data integrity and trust. But on the other side, you've got these massive, real-world hurdles. For example, that proof-of-work system that makes Bitcoin so secure, it also uses an absolutely enormous amount of energy. And that immutability we were just praising, well, that can directly clash with privacy laws, like Europe's right to be forgotten. These are the really tough trade-offs that developers are trying to figure out right now.
And the Czech National Bank points out something really fascinating here, a kind of paradox. To solve some of those big problems, like speed and scalability, many of the newer blockchain applications are actually bringing back little bits of centralization, which kind of goes against the whole original vision. This quote really nails that tension.
And so all of this leaves us with the really big question, doesn't it? Is blockchain the fundamental building block for a more transparent, trustworthy digital future? Or is it a brilliant solution that's still trying to find the right problem to solve? For now, the answer is still being written, one block at a time.